Today in Math 30-1 we're looking at topic 4.4, Introduction to Trig Equations. Now first of all let's look at the notation. You'll notice there's square brackets around 0 and pi. This represents the interval from 0 to pi inclusive, and it's another way of writing that their angle theta has to be between 0 and pi but less than or equal to on both ends. Now, here's how the terminology works. If our angle, theta, is an element of 0 to pi, you'll notice that there's round brackets. This means that theta has to be greater than 0, but less than pi. Now, if you'd use the same thing with a square bracket and a round bracket, notice that it means that theta has to be greater than or equal to 0, but less than pi. In example 1, we're going to solve trig equations. Solve each trig equation in the specified domain. A, 5 sine theta plus 2 equals 1 plus 3 sine theta over the interval from 0 to 2 pi. Notice that theta has to be greater than or equal to 0, but less than 2 pi. We want to know all the solutions, and because theta is represented between 0 and 2 pi, we want our answer to be in radians. So here we go. 5 sine theta plus 2 is 1 plus 3 sine theta. Notice that I have 5 sine theta on one side, 3 sine theta on the other side. If I subtract 3 sine theta from both sides, I'll end up with 2 sine theta plus 2 is equal to 1. Now, I want to isolate to find sine theta, so I'm going to subtract 2 from both sides, and I will end up with 2 sine theta is equal to negative 1. At this point, I can divide both sides by 2 to get sine theta equals negative 1/2. Now I have to ask where, over my unit circle, is sine theta going to equal negative 1/2? Well, if you look at your unit circle, remember your cast rule, where is this going to be negative? Sine of 1/2 is 30-degree angle, or pi over 6. And so where is that going to be negative? Well, it's going to be negative at 7 pi over 6 and at 11 pi over 6. Apply the cast rule. Next, B. 3 cosecant x minus 6 is equal to 0. This time, it's over the interval between 0 and 360. Now I can give my answer is expected to be given in degrees. That's the key. That's what you have to look for. So here we go. First of all, add 6 to both sides. Divide both sides by 3, and the cosecant of x is equal to 2. If I take the inverse of both sides, I will find that 1 over cosecant, which is sine of x, will equal 1 over 2. And when is the sine of x equal to 1 over 2? Well, it's going to be at 30 degrees, and between 0 and 2 pi, it's positive, so it's also going to be at 150 degrees. The other two are going to be negative, so that means that those are the only two possible answers. In example 2, again solving for theta, in tan squared theta minus 5 tan theta plus 4 is equal to 0, between 0 and 2 pi. Give exact solutions where possible. Otherwise, give approximate angle measures to the nearest thousandth of a radian. Okay, when you look at this first of all, tan squared theta minus 5 tan theta plus 4 is equal to 0. This looks just like a quadratic equation. Maybe I can factor it to find my solution. So it looks like a quadratic equation. Can I factor it? Well, it's going to behave just like x squared minus 5x plus 4 is equal to 0, which I know I can factor as x minus 4 times x minus 1 is equal to 0. So there's two possible solutions. X could equal 4 or x could equal 1. That means if I rewrote tan squared theta minus 5 tan theta, I could factor it to be tan theta minus 4, and tan theta minus 1 is equal to 0. This is going to give me two possible solutions. Tan theta minus 4 is equal to 0, and tan theta minus 1 is equal to 0. Remember, if x minus 4 is equal to 0, x will equal 4. Or if x minus 1 is equal to 0, x is going to equal 1. Same procedure works here. This way we're going to say tan theta is going to equal 4. There we go. Tan theta is equal to 4. Or tan theta is going to equal 1. Well, we know tan theta is going to equal 1 at pi over 4 and at 5 pi over 4. Those are my exact answers. However, when tan theta is equal to 4, I don't have an exact answer for this one. Therefore, I'm going to have to use some approximations. So the tan inverse of 4 is going to equal 1.3258. Now, remember, that's going to be in quadrant 1. There's also going to be another solution, and that one's going to be in quadrant 3. So in quadrant 3, our angle is going to be pi plus the reference angle. Because according to our cast rule, going back to this, notice that the tangent is going to be positive in quadrants 1 and in quadrants 3. So here we go. This way, we can now say that it's going to equal pi plus 1.3258, which is going to give me 4.467. So now I can go and say that my solutions are 5 pi over 4 and pi over 4. Those are the exact solutions. And I can also say it's going to equal 1.326 approximately and 4.6467, and that's correct to the nearest thousandth. And those are going to be our two approximate solutions. Moving on. Next example, example 3. The general solution of a trig equation. Let's solve for x in the interval between 0 and 2 pi if sine squared x minus 1 is equal to 0, and give your answers as exact values. For part B, determine the general solution for sine squared of x minus 1 is equal to 0 over the real numbers if x is measured in radians. Well, we'll get to that. In A, we have our equation, the sine squared of x minus 1 is equal to 0. So a couple of different ways we're going to solve it, and the first one is going to be, let's look at using the square root principles. And that is, if sine squared of x minus 1 is equal to 0, I can say that the sine squared of x is equal to 1. And if I take the square root of both sides, I'll get the sine of x has got to equal the positive or negative 1. Now, sine of x is going to equal positive 1, or the sine of x is going to equal negative 1. Sine of x is going to equal 1 at pi over 2. And the sine of x is going to equal negative 1 at 3 pi over 2. Remember from our unit circle, pi over 2 is going to be the point 0,1, and 3 pi over 2 is the point 0, negative 1. Now remember, I said that there was going to be another method of solving this, and that could be to factor this. We could say sine squared of x, or sine squared theta minus 1, can factor as a difference of squares into sine theta plus 1 times sine theta minus 1 equals 0. So again, it's going to take us to the same spot because it means the sine of theta has to equal negative 1, or that means the sine of theta has to equal positive 1, which is already where we were in the first part. Now, For part B, we need to find a general solution. What this means is that you have to think of coterminal angles. If one of our solutions is at pi over 2, every time you go around the unit circle, you're going to land back on the same pi over 2, which would be pi over 2. The next one would be 5 pi over 2. The next one would be 9 pi over 2 as you moved around and around the circle. So if you think of coterminal angles, that's what you need to show. So one solution is a pi over 2 plus 2 pi times n, where n is any integer. And the other answer is 3 pi over 2 plus 2 pi n. Every time you go around the circle 2 pi radians, you're going to get the same point, and it'll be part of your solution. So you need to express all of those as your general solutions. In summary, our key ideas. To solve a trig equation algebraically, you can use the same techniques you used in solving linear equations and quadratic equations. When you arrive at the sine of theta is equal to a, or cos theta is equal to a, or tan theta is equal to a, where a is any real number, then use the unit circle for exact values of our theta, of our angle, and inverse trig function keys on a calculator for approximate measures. Again, use reference angles to find the solutions in your other quadrants and the cast rule. To solve a trig equation involving the cosecant, secant, or cotangent, you may need to work with the related reciprocal values. And to determine a solution, a general solution, or if the domain is real numbers, find the solutions in one positive rotation, which is 2 pi or 360 degrees, and then use the concept of coterminal angles to write an expression that identifies all of the possible measures. So now, your assignment for today, day 1, is to do page 211, 1 to 7, 12, and 18. For tomorrow will be the chapter 4 review class, and I want you to work through page 215, 1 to 23. And that'll be to prepare for your Chapter 4 quiz.